Imagine a home that stays comfortably cool in the summer and cozy warm in the winter, all without your heating and cooling systems constantly running. It sounds like magic, but it is actually smart design, and it relies heavily on something called thermal mass. When it comes to the single best indoor thermal mass material, there is not one universal champion, but several highly effective options stand out. Materials like concrete, brick, stone, and even water are excellent choices. They all share specific properties that make them superb for moderating your home's indoor temperature. The core mechanism behind thermal mass is its ability to absorb, store, and then slowly releases heat. Think of it like a natural battery for warmth. During the day, especially with passive solar design, these dense materials soak up excess heat from sunlight or your home's internal heating. Then, as temperatures drop in the evening or overnight, they gradually releases that stored heat back into the living space, creating a much more stable and comfortable environment. This works in reverse for cooling too, absorbing heat during the day to keep interiors cooler. The effectiveness of a thermal mass material hinges on two main properties: its specific heat capacity and its density. Specific heat capacity refers to how much energy a material can store per unit of mass. A high specific heat means it can hold a lot of heat without a drastic temperature change. Density relates to how much mass is packed into a given volume. Denser materials typically have more mass to absorb and store heat. Concrete, with its high density and good specific heat, is often a go-to choice, followed closely by brick and stone. Incorporating these materials effectively means strategic placement. For example, a polished concrete slab floor directly exposed to winter sunlight is a classic passive solar design feature. You can also use masonry walls, either structural or non-structural, on the interior of your home. Even large containers of water, sometimes hidden within walls or under floors, can serve as excellent thermal mass due to water's incredibly high specific heat capacity. Maximizing the surface area exposed to direct sunlight or ambient room air greatly enhances their performance. Beyond traditional materials, there is an exciting area called phase change materials, or PCMs. These materials store and releases heat as they change their physical state, say from a solid to a liquid, rather than just changing temperature. They can pack a lot of thermal storage into a smaller volume, offering advanced solutions for thermal regulation. Imagine a special type of drywall or ceiling tile that can absorb a huge amount of heat just by subtly melting, and then releasing it when it resolidifies. These are truly next-level components for sustainable building. By thoughtfully selecting and strategically placing thermal mass materials, you can significantly reduce your reliance on conventional heating and cooling systems. This not only leads to noticeable energy savings and lower utility bills, but also creates a home that feels naturally more comfortable and resilient. It is a fundamental principle of passive design that empowers you to create a more sustainable and enjoyable living space.